come on, this printer's horrible. What do I do? That could work. Nah, I'm just kidding. My printer is completely fine. But this is my take on a LEGO printer. I'm Ishu, and you're watching Ishu Builds. This printer is actually inspired by JK Brickworks LEGO printer. His video is down in the description below. Please check that out. This printer is made using LEGO Mindstorms EV3. It has the main brick over here, 3 motors, 1 touch sensor right there, and 1 color sensor down there. This printer takes input in Morse code, so if we grab a touch sensor and click it into port 2, like this, we can use this touch sensor to input Morse code into the printer. Now, let's see the printer in more detail. So, starting from the front, we have our main motor right here that is connected through an axle to this wheel here and this wheel here. This allows us to insert paper into our printer. So, here we have our paper. If we just put it into our pin controller like this, and if we just spin it, as you can see, the paper goes through the printer and can come out the back. Here we have our printing head that houses the pen. So here we have a pen, kind of a Sharpie instead. What we can do is we can rotate this part and insert the pen into the printer head right like this. The printer head houses the pen so the pen stays stationary. If we move the paper up and down using these pin controllers, we can make a vertical line. Now, let's go on to the back. So, this is the back of the printer. This motor right here controls the horizontal axis for the printing head. This over here is the printing head. As you can see, as we rotate the motor, the printing head moves left to right, making a horizontal line on the piece of paper. Here we have our motor that controls lifting the printer head. So if we move this motor down, it places the printing head down. And if we move it up, it lifts this beam, which is connected to the printer head, and lifts the whole printer head up. This helps us lift the pen up if we want to give spacing or if we want to add a space between letters. This is the first problem in the printer. This beam lifts up higher here than here. This causes the pen to be lifted higher up here and lower down here, which causes any pen movement here to still be put on the paper even though the pen is up. If I move this paper back out, we have a color sensor right here. This color sensor waits until it detects white, like the piece of paper, and stops these motors, the motor from working, and stops the pin controllers and makes the paper stop perfectly under the printing head. This is the touch sensor. The touch sensor tells the printing head over here when the pen is on the leftmost side. So if we keep on moving the pen, it will eventually touch the touch sensor, showing it that the pen has came to the leftmost side of the printer and it should stop printing, and then it should move on to the next line and continue printing that way. Now that you guys have seen the printer's mechanism in detail, now I'll show you guys the code. The code is written in Mindstorms' own block-based programming language and code editor. So, now we move on the coding part of this whole printer. So, it's a pretty simple printer here. This code may look a bit complicated, but it's pretty easy once you understand it. So when we start the whole printing process, it initializes a couple variables, which is fine. Here is the main Morse coding part of the whole printer. So it waits until a touch sensor input is detected and a timer is also started. If the timer takes 0.2 seconds or less to be clicked in, that means we had a dot. But if it takes any longer, we press the button, that means we will input a dash. So this is where we input all this into a variable called Morse code. If we wait for more than 2 seconds though, what will happen is that Morse code will be gone through this list or kind of if case where 1 is a dot and 2 is a dash. So it converts all of these into these numerical values that can be put into a numerical array, because EV3 doesn't allow you to make a lettered array. So what this does is simply A is 11 all the way to Z, which is 36, and then spacebar is 37. And then it displays the Q. So this display Q over here is also a relatively easy thing to hear. It takes a printing Q, and what it does is it reads the index. If it doesn't have anything, the length is 0, it displays nothing. If it does, it initializes an X and Y coordinate. So that's the X and Y coordinate of where the letter will be put on the screen. So it clears the screen first, and then it goes through, and if there's already 20 characters, it will increase the Y value. So now you can move letters down a row. And if there's less than 20 letters on the row, it will continue and it will just go through and print depending on the values. For example, 11 again is A, and then 12 is B, so forth and so on like that. And I'll keep increasing the X value to just, increase everything. So this is fairly simple code right here. Going back to the program code, the main part in which it's taking the Morse code input, that's all. That's mostly the Morse code input. And this loop terminates, so this keeps going in a loop, but it only terminates when this loop integer value over here is true. So if we come down here and look at this code is for deleting or pressing OK for printing. If we click the down arrow right here, it will delete the last character that you inputted. If the length is 0, it will just write the array to be nothing, or it will go through and rewrite the whole array and then just remove the last character. That's pretty simple. It will just remove the last character. But if we click the up arrow over here, what will happen is the loop integer value becomes true, truncating this loop up here. And then it goes on to this printing my block here. This printing my block is a very important block which shows us everything that is related to printing. That's calibrating the printer and then actually printing it. So let's go in here. Let's scroll all the way back. A lot of code here. So thing 1 it does is it checks the length. If the length is greater than 88, it will turn off and truncate this code, telling us that the inputted characters are actually longer than 88 characters, and the printer cannot fit that in. Next, if it is less than 88 characters, we move on, we initialize a couple of variables here, and then this display printing status. This displays if the printer's calibrating or printing. So let's go into this. Here you have the actual length, how long it is, and then the index. So this, you can make a percentage out of this, and this type true and false, I'll show you guys in a bit right now. If it's true, it will read calibrating, and if it's false, it will read printing. This is done so I can reuse the same my block for both calibrating and printing. So it shows calibrating on the top, and then here this code shows us the percentage completed. So it can either show calibrating 2% completed or printing 5% completed or something like that. So that's how that works. Going back to printing, it will now do this array operations. The reason I have this calibrating percentage kind of measurement, because EV3 takes a very long time, for I do not know what reason, to do array operations. And for that, you do not want to be waiting 15 seconds with the printer doing nothing and having nothing displayed. So that's why we have a counter to show you the percentage of how much is done. So moving forward, all this code over here is related to a simple thing that we're doing, is if a word cannot fit in the line, it will go down and be placed in the second line. This makes out whatever you print come much cleaner. And if the word is longer than 11, that is how much characters you can fit in one line, it will just break the word up and fit it in 2 lines. So, this is how it works. If it is 37, that is a space. If there's a space, it will go up here and check if the word is greater than 11. If the word is not greater than 11, or if it's less than 11, what it'll do, it'll check if the word can fit in the current line. It'll fit it in the current line. If it's not, it will move down the line and fit in the next line. This is all array operations. This is not physically happening. It's making a separate array that in which, again, A is 11 all the way to B, which is 37. But if there's a 50 in between the array, the 50 just tells the whole printer to move down a line. So it just inputs 50 right before or after the word, telling the printer that, hey, the line's full, now you have to go down. But if the character is, in fact, greater than 11 characters long, it will print the word in 2 lines, or else it'll result in an infinite loop. Here, on the other end, it does the same check if it's greater than or equal to 11. Over here, same check. But this check actually, what we do is we actually check if there's a space bar. Because if there is a space bar, it has to remove the space bar going down a line. So if we don't go down a line, the space bar is fine. We need a space bar. But if we go down a line, we'll just have a missing character. So if we go down a line, we remove the space bar right here. Now, going through, now we have a nice big array of bunch of numbers. So 11 to 37, again, is all numbers and then the space bar. And 50 tells us that we have to go down line. The reason I use 50, if in the future I want to make this printer also print numbers, I have space for that. Here, we just calibrate the pen, then we calibrate the pen, we insert the paper, then we align the pen. All that I'll show you guys in a bit. But here is the main printing part. Again, here's a reuse display printing stats code, which now is in false, so it shows printing completed, let's say 5% or something. Same thing here, it shows how much percent is completed. 11, look at that, we can print the letter A. 12, we can print the letter B, and then this increases the index. So first, let's go through these letters. So if we see letter A, this is how I print one letter. So this pen rotate moves the pen up and down. If the pen is down, then it will print anything. If the pen is up, we can give spaces or spacing between letters, and the pen will not print anything. Simple, you put the pen down. So this first one puts the pen down. And then B motor, moving positive is down, moving negative is up. The A motor, moving positive is to the right, and moving negative is to the left. So this, we write these motors, and this will print out a simple letter. 60 is the height and width of one letter. So 60 here and 60 here. A 30 would be half of the letter. So if we move the B motor positive, so it goes down. B motor moving negatives goes all the way up. A motor moving positive moves it to the right. B motor moving positive goes down. B motor negative, but it only moves 30. That means it only moves half up. A motor negative, that means it goes left. A motor positive, it goes all the way right. B motor negative, but again, only 30. It goes halfway up, so that's half plus half is the full thing. And then it picks the pen up and it adds some letter spacing. This spacing just adds a tiny bit of spacing, so the next letter that's printed has a bit of space. Same thing for the pen rotate. It just lifts the pen up, so it moves half a rotation, lifting it all the way up. Calibrate pen. So this command over here is pretty simple. It moves the A motor until the touch sensor is touched, and when it is, it will stop, and it will move the motor back to the center. So this is how I get the pen to the center. Insert paper moves the B motor until the light sensor detects the color white, and then it stops the B motor. Align pen is kind of similar to calibrate pen, but this aligns it all the way to the left edge with a bit of spacing, so we can print letters more easily. So this moves the pen all the way to the left until the touch sensor is touched, and then it adds a tiny bit of spacing. So, also, while we're at the code segment, I wanted to show you how I print diagonal lines also. So here, this is how I print diagonal lines. I run both the motors in a move tank block with inputting powers and then how much they want to move. So 30 degrees and 100% power means both the motors are going to move half to the right and half to the down. So all of this enables us for us to print diagonal lines. And that's really all there is to this printer. Apart from it shows that printing's complete and then it removes the paper. So this just runs the B motor for a bit until the paper is completely out. So that's actually all the code. I do not have enough time to go through and explain this code in very much detail. So in the next video, I will actually show you the instructions for this printer. And along with those instructions, I will also give you guys the files for all this code. And that's how you guys can, make and use this printer for your own good. So now we're done with the coding part. Now let's move on. Now that I've shown you guys the printer in detail and the code, now let me show you how it actually runs. So here is the final output of the printer. It's not perfect, but it's good enough. Next video, I'm going to give you guys a tutorial on how to actually build the printer and also give you guys the code for it. Thanks for watching. Bye-bye.